All right, let's get right into it. Today, we're going to tackle one of the most important questions in artificial intelligence. How do we actually know if an AI is smart?
Okay, so this is really the heart of the matter. Is the AI actually understanding the material, or is it just cramming facts like a student who memorized the textbook the night before a test? We have to know if it can take what it's learned and apply it to totally new problems. You can think of this whole process as the AI's final exam.
Right, first things first. To give our AI a fair test, we have to separate its study materials from the actual exam paper. In the AI world, we call this training data and testing data. The training data is like a massive study guide, just packed with questions and all the correct answers. The model pores over this data, looking for patterns and learning how things are connected. But the real test, that's the testing data. This is a surprise exam. It's full of questions the model has never, ever seen before. How well it does here tells us if it has genuinely learned or just memorized the study guide. Okay, let's move on to the first subject our AI can major in, regression. And this one is all about predicting numbers. We use regression whenever we want to predict a specific amount or quantity, like forecasting. It's what we call a supervised method, which is just a fancy way of saying its training data, that study guide, is labeled with the correct answers. It helps the model learn the relationship between the inputs and that final number it's trying to predict. So, what does this actually look like? Well, visually, a regression model's whole goal is to draw one single best fit line right through a cloud of data points. That line is the model's best guess about the underlying trend. It's trying to get as close as possible to all those little dots at the same time. And this isn't just some abstract theory. Regression is literally everywhere. Businesses use it to forecast their sales, Wall Street uses it to try and predict stock prices, and websites use it to estimate how much you could rent your house up for. It's always trying to answer how much. Now, there are two really common ways we measure this error. First is mean absolute error, or MAE. It just takes the average of all the mistakes. Simple. But then there's mean squared error, or MSE, which is a much tougher grader. It squares the errors before averaging them. So what does that do? It makes big mistakes really hurt. An error of 10 doesn't just count as 10, it gets blown up to 100. But a tiny error of 2 only becomes 4. So you use MSE when being off by a lot is a complete disaster, like getting a house price wrong by tens of thousands of dollars. Let's move on to our AI's second subject, classification. Now, if regression was all about how much, classification is all about which one. It's the art of sorting things into different boxes. Just like regression, classification is a supervised learning task. So again, it's learning from data that's already labeled with the right answers. But instead of predicting a number, it's predicting a category or a label. The classic example, an email filter trying to decide if a message is spam or not spam. And here is the absolute key visual difference. Instead of a line going through the data points, a classification model learns a decision boundary that goes between the groups of data. Everything on one side of this line gets labeled as one thing, and everything on the other side gets labeled as something else. It's literally drawing a line in the sand. And you see this constantly. When a bank decides on a loan application, a model might classify it as approved or denied. That's a binary classification, just two options. But when your phone looks at a picture and identifies a cat, a dog, or a bird, that's multi-class classification because there are more than two possible outcomes. But what happens when our data has no labels at all? What if the AI doesn't have an answer key to study from? Well, that's where our third subject comes in, clustering. And this is what we call unsupervised learning. With clustering, we basically just give the model a whole mess of data and say, find the natural groups in here. The model has to look at all the features of each data point and figure out which ones are similar enough to be clustered together. It's a process of pure discovery. A perfect real-world example of this is customer segmentation. A big company can use clustering to analyze all its customer data and automatically find groups like big spenders, new customers, or weekend shoppers, all without anyone having to label them first. It's also amazing for anomaly detection, finding that one weird thing that doesn't fit in, like a fraudulent credit card charge. So we know how to grade the AI using metrics like MSE for regression or accuracy for classification, but how does it actually study? How does it get better and improve its score? The best way to understand this is with an analogy. This is for the most common learning method, and it's called gradient descent.
I want you to imagine that our loss function, that measure of how wrong the model is a giant foggy valley. The very bottom of that valley represents the lowest possible error. That's our goal.
This table is the perfect summary for your revision notes. Look, regression and classification are both supervised. They need that answer key. But clustering, that's unsupervised. It finds patterns all on its own. And remember those key visuals: a best fit line, a decision boundary, and grouped clusters.